Hello students, welcome once again. Today we are going to learn a very important concept, that is about 1 and onto function. So we are going to learn which kind of function are 1 onto function. We have to learn this because if we understand what are 1 onto function, then we will be able to define inverse function. We will be able to define inverse function. So students, what is your aim? Your aim is, as of now, you can say my aim is to learn what are 1 and onto function. If I understand what are 1 and onto function, I'll be able to define inverse function. Okay, so let's begin. I have written here some important points. You need to follow those points. This lecture is going to be very interesting. You are going to enjoy this. Very interesting, very important. Some important points to be remembered. As I go ahead, each and every point I'll be making you understand, and I suggest you that you should write these points in your notebook. Listen students, if y equals to f of x, you write y equals to f of x means y is a function of x. So wherever you see such an expression where you notice y is explicitly expressed in terms of x, what is meaning of y? Y is explicitly expressed in x. It means one side, on the left hand side you have only y, and the right hand side you have terms of x. So you say y is explicitly expressed in terms of x. This is y equals to f of x. Y equals to x square minus 5x plus 3. This is y equals to f of x. Y equals to log of x plus 5. Y equals to f of x. See, these are y equals to f of x. So whenever you write y equals to f of x, what does it mean? It means y is a function of x. Further, that is, value of variable y depends on value of x. Students, this is self-explanatory. You can understand when you are writing y equals to x plus 3, what is going to happen? The value of x you will decide, okay, and that value of x, y will get you the value of y, okay. You will decide a value of x when you write, say here you have y equals to x square minus 5x plus 3. So what happens is y is a function of x. The value of y will depend on x value. You decide one x value, then that x value you substitute in place of x, you calculate, and that will get you y value. X is a variable. X is going to take various numbers as its value, and for every such x value which you will substitute, you will get y. So y is also a variable, but remember students, the value of y will depend on the value of x, and that is why we call x as independent variable. X is independent variable and y is dependent variable. That particular statement will come ahead, okay, which I have already explained. Now go to the next statements. The next statement, students, is when we say that y equals to f of x is a function of x, then we mean that for every value of x in the domain of f, there will be a unique y value, that is one and only one value under f. Under f means under the function, under the mathematical rule. Students, we are going to learn this much in detail, and I'm sure you will understand this, and once you will have understood, you will feel much smarter about mathematics. Listen students, this particular statement here, let I will make here two stars and see what these two stars actually indicate. See, one star I will make here where I have got the word every, in bracket I have written all. Now the meaning of every and all, as of now, as of this place, is same. By writing every I mean all. So here see, and the second star I make at this place. Now remember students, whenever here what you have here, you have unique y value. Remember students, whenever you have y equals to f of x kind of thing, you have some expression of x on one side and the other side you have y. So what happens is there is a rule defined, there is an underlying rule defined between x and y, as you wrote, as you saw here. Now see, when you say y equals to x plus 3, when you have y equals to x plus 3, there is a rule between x and y. And what is that underlying rule? The rule here is every y value will be 3 more than the x value. The rule here is every y value is 3 more than the x value. Now this particular rule which I made in the English statement, the rule which I said here, every y value will be 3 more than the x value. This rule, mathematical rule, is the function. It is the function. Okay, so remember students, when you are writing a function, what you see is an equation. But remember, at the back side of that equation, you can say behind the scene, there is some mathematical rule working. Same would be the case here. What will be y value? You can always put this rule in English language. Okay, the y value will be 3 more than the difference of x square and 5 times of x. Okay, or here you can say the y value will be 5 more than the log of x value. So this kind of rule which you have, it is known as the function. Okay, come back once again to the statement here. See here, what I had written here was, okay, students, so here what I had was, when we say that y equals to f of x is a function of x, then we mean that for value of x, every value of x in the domain of f, there will be unique y value, that is one and only one y value under f. Okay, so here what I want to say is, what the statement is, if you have say y equals to f of x. Now when you have y equals to f of x, uh, on the right hand side you got some expression of x. Okay, and then this x, which is a variable, this x is going to take numerous values. It will take numerous values. It will take numerous values, and these all x values, say these many x values you have. Now for every x value, what happens is, see, when I take this x value and substitute in the function, this particular x value, when I substitute here in the f of x, and I notice that for this x value I got some function value or y value, because you are writing y equals to f of x. I'm getting, if I'm say here, if I write x1, if I write here x1, so when I substitute x1 here, I'm getting y1, I'm getting y1. And for this x1, this value y1, I notice that it is unique. It is unique. Then if I'm writing this, if I'm writing, say here I have x2, so when I substitute x2 in this function, I notice that I'm getting y2, which is once again an unique value for this x. Then if I'm writing x3 and substituting here in the function of x, I'm going to get y3. What I notice is, every single time when I take one x value from this set is domain set, when I'm taking one x value from this set and substituting here in the function, what I am noticing is, every single time I'm getting a unique value of the function. I'm getting unique value of the function. Furthermore, as I said here, that for every values of x, that means none of these values would be left out without giving you a unique value of y. That is, for this x you will get some y, for this x you will get some y, for this x when you substitute here you will be getting some y value, for this x you will get some y, for every x, for every x, for every x you will get some y value if this is a function. If this expression, if this expression is not giving you, if this expression is not giving us some value of y for any of the particular x value from this set, then this expression will not be considered a function. Why? Because this expression fails, this mathematical rule fails to give us a value for a particular x value, for a particular x value. It has to give us a unique specific y value for every x value. Okay, so the later part will come in next video. Thank you.